Hello everyone, welcome back to KillerRabbit Codes, and today we shall be adding unions to our interpreter. Now I'm putting some of the logic, but the only logic I added is like adding of types, creating of the union table builder stuff, and now we should be able to add unions. So, just add another table entry here. Union, and this can be loaded whenever, whereas the bytecode and function table are both required, they exist at the same time, so we could just handle it here. So I always forget it's been a while. I'll check back what the union table has. It's not helping me. Let's see, we have the amount of unions, we have an iterator, which is probably just what we want to do. So, I'd call it UN because union is a reserved keyword in Rust. And union table.iter. And each union, we'll just need the variant iterator. So we need actually, what do we need to build a union? A union has a size, a name, and the number of variants. So we do let root variants, and that will be a vec. Actually, I think we could figure out. Oh, yes, we can. So capacity, variant size as use size, and then for each variant. That's not what we want. We want variant issue. There we go. Oh, that's not what we want. No. There we go. So now we have union variant. Alright, and then we need to see. Construct the union variant. Mute variant types. So I think I could do var dot types dot len. That will pre-allocate, and then actually we could do the, no, we could do better. Var dot types dot into iter. We can now chain it. Map. And then do map type. Also, a type is technically not. Oh wait, we need to go raw. Technically, this shouldn't be an U32. It should be an I32. So let's fix that. There we go. Map type, and we dereference ty, and that gives us an index into the type table, which the issue is how do we deal with types that are in the type table. We need to deal with that, but luckily right now we do not support union types in unions currently, so the raw module format definitely does. And sorry about that, power fluxed, but we are going to map the type over to an index, and we'll have to modify the map type at some point to allow us to handle unions and function types. But for now, we're just going to collect collect it. This is probably a deck of type. Come on. So what is type? Let's see, types, type, there we go, and I need to pull up tables, there we go. And we will need module C raw, and then we need, where are you? Type table. Hold on. Union table. There. Oh, okay. I see. Index equal var dot name. Name equal string table dot index of name index. And then what to do? Let name equal strings, add string and names as bytes. And then now we have that. We go back to unions. Actually, we don't even have to do that. Yeah, because we do want that. Actually, you don't need to do that. We need to do variance, push, union variant. We want unions. Union variant. And then we just need to provide the name, which is the index, and the types, which is just variant types. And that. There we go. There we go. And okay, now we need to calculate the size, which we could technically do it on the fly, but yeah, let's do it on the fly. Why not? So no, let's not do it on the fly. That seemed it's much easier just to no, we'll do it on the fly. Types is going to be a types type, and this will calculate padding. Alright, so can I put constants here? Like, can I go type unit? Unit will do funky stuff, so can I put you there? Yes, I can't do that. Ah, okay. Maybe if I do that, I can do that. Maybe. That's fine. Yes, that's fine. This is a type that should not be here. Technically, we should just panic, but I'd rather quietly air out here. Type are the types. Eight is 1, this would be 2, 3, 4, 8, 4, 8, 16, 32, 64, F32, F64. I forgot int. So this is also an 8. I actually think everything else is just 8 now thinking about it. But Well, now we need to figure out the padding, because we're just gonna stack U8s on top of each other until we reach a 68-bit or 8-byte, and then 16 would be somewhat the same way. So there's a little bit of logic here. While size not divisible by 2, now this just adds padding. We'll do the same here. Yeah, this is 4. And this will be the same, but 8. I think these two are also the same for... And those, technically this logic is shared here. And let's add some notes. Let's do it. Padding of padding of unions of union variants. There we go. And we can go back here. We have that, and then do size equals calculate size and type variant types, and then if max size is smaller than size, then max size is equal to size. And then we go back to unions. And now we can construct a union. And so what we'll do is unions, add union, equal strings string table dot index name index let index index in name equal strings dot add string. You will do name dot as bytes. And that needs to be as usize. And then now that we have that information, we can do add union, put union name, and then we'll put in a new union, which we shall just do a unions union, and max size index. Variance, and we should do that. Why are you complaining about that? It's a string index, which, oh, not union index. Union index. There we go. Now we've loaded in a new union. But now we need to mess with the bytecode for dealing with unions, which will be down here. Oh yeah, the way the code's changed, I did use Claude to help refactor this because it was a nightmare, the edit. But basically, this now inserts the handler function into the bytecode, and then decodes that handler function and executes it. So as you can see, there's a lot of stuff, but also this might change if I find a way to spin up the interpreter, so it'll probably get refactored by Claude again. Hopefully AI has gone. Hopefully either this is where things get interesting, because I'm like, hopefully either AI gets more expensive then, and the world doesn't destroy itself, or hopefully it's still cheap, so I can do the refactor. And I'm hoping that it's the former is more true. Anyway, but alloc union. Oh, okay, dang, I need to open up. No, that's not what I want. I need to go to raw. Hi. And this is where I need to see. It's not helpful. There we go. There. Okay, so I assume the bytecode. But now I'm curious. So alloc will take the name and the variant. The variant's useful because that's how we know what to pop off the stack. So my imagining is that we have a let union name equal, yeah, it's a name, so let union name equal read a U32, let union variant read U32. And this is where I realized all unions need to be loaded ahead of time, otherwise we don't know what the variant is. Because we need a variant. We probably want the variant index. So let's go back up. And we probably want to do basically this loop, but load module data. And we don't have that function, but we have this, so I'll just yoink you. Load module data, and then realize that we need to do that, so we get a reference. And we don't care about really anything is here, so unless it's an error. So this is going to be probably unit. I want this loop module is going to be, that's probably fine. Oh, I see. I don't really want to clone that. I mean, it's one allocation, so I think this will be not that heavy. So now we can do what's that? Iter. I was complaining about this module. It should theoretically just be copy, but don't care. Oh yeah, we need to go down here and do OK. And now we can ignore that. Did I import? Yes, I imported this into that scope. So, string table. Oh, we need to get the string table. Yes. We probably don't need either of these. And then we just load all unions in. And so we should always have a union table. And the types, I guess, also get loaded in. Should they get loaded in now? Load you duplicates. Maybe? I think it'll be fine to load them in now. Which means that we technically do not need to handle them here anymore, because they already get loaded in. Alright. And now that we've loaded in the unions, you can now trust that they'll appear in here. Alright, so now we need to look at what interface the unions provide us. Probably need to add a function to look up the index. This is probably not need to be static, but this should return a union index. And so this should theoretically pass. This should always work as long as there's not a missing hole. So I'm going to just say that self.map.get name expect Actually, no, it shouldn't. It should be an option because then I can handle the error in the linker. There we go. Alright, so now use the unions. Also want how do we know what variant a union is a part of? Oh, I guess we could do it is 256 different variants, and I don't think most variants will be 256. Which makes you think that maybe we could get away with just a straight lookup, but we probably shouldn't. If I'm being honest. So I'm going to add another field. Variant name. Variant name. This will just be a U8. So that means we'll add another hash map. This will be pretty much this inside U8. It's not called map. It will be variant map. All right. So now add union. This will take in be a variant map, which is a hash map of static string to U8s. And why is that like that? Insert name and variant map. So let's be variant map, get that. And then we have a hash map, and we're going to do an x.get variant name, and then do a flatten map. And do that. And just because I like style, this is going to be like this. Come on. There we go. Which means now I need to go back. Oh. I just need to go back up here. We add the union. Let mute variant map, hash map. And so we will need this now. So variant map dot insert name and I as U8. And then we add the variant map. Now we're back here. And we can look at the union name, the union index. So some union index equals union name equal, let's see, union, unions, wait, hold on. This does not have unions in it. Into a builder. Unions there. Then why is this complaining? Oh, because I don't need this anymore. Is dot lookup. First, I'll need to get the equal string table index your name as usize, let index and union name equal strings dot add string name as bytes. And basically it's the exact same logic here. Variant index and variant name. Variant. There we go. And so now we can just look up. These strings should already be in there, but we need to know what their indexes are, so might as well just figure that out now. So what we'll do is look up in name. And this should be return error, linker error, missing entries, perhaps. And then union variant will be variant name. Actually, probably don't need the index. And then I want the union variant equal union variant as a variant name and union name as a U32, because that's how the new bytecode format works, is we keep everything as size as a U32. And that allows weird, funky optimizations to take place, and I don't know the story behind it exactly, but the Rust compiler likes that. Alright, so this means that we can now do some of these even work? It's been a while since Okay, I think I understand now. Wait, where was I? Alright, there we go. Emit handler. That's a linked bytecode and task. Do we have... Hold on. Let's do it from here. Alright, do we have a alloc? Do we even have an alloc? So it's after make closure. Oh, it's a union. It's under union op because it's doing weird stuff. I want make closure. Let's just take this one. So let's call it union alloc, and then we'll go over here and put in union alloc and not call it. And lower rather, equal union index ANDed with 0x 2 4. That will give us the lower bytes, and then want an upper. And it's easier to do because we just have to shift down 8. No, 32 bits. And then we want to do bytecode dot push lower, push upper, push union variant. And what is going on here? Oh, I know why. It's yelling at emit handlers converting of a function pointer into a number. So with that, we can now allocate a union. Well, until this handles it, that is. And so we want this. Oh, not that. Union alloc. And what we want to do is want to increment is the new system. What it does, it threads the pointer through the code pointer through, and so it's our job to ensure that the handler properly increments it. So just for the heck of it, we're just going to do an unsafe. Hold on. Code add. And it should be 1, 2 for the function, 2 for the name, and 1 for the variant. So that's 5. And so what we need to do is actually I'm gonna check the exact logic of dispatch. Yeah, okay, that's what I thought. Okay. So what we need to do is let lower code dot add to the skip over the function. That'll be add 3 to get the upper, and then do let union index equals lower as 64. No, upper use 64 shifted 32 ordered with lower as use 64. So I'll need another these, and then I need to get let variant unsafe code add 4 as U8. And then now we need to go, I'll take over this window now, and then we need to go to bytecode, internals, alligator. That. And now I need to add a new allocator function. So I'll put it at the top of heap allocator. Union, which will be union index, which would be a union index, and int union no, this is a U8. And then this should return a object. Actually, it'll just return a heap value. And now thinking about it, we need to pass in task. So that we'll need a task, which is a mute task. Why don't you, yes. And so we need to do, let's open up the unions again. And we want to get that union. Let's just do this. Equals union table index, union index. And now we got our union. And then we'll layout equal layout new object that. And then I'll do let. I forgot the values are. Okay. All right. So layout, and then we want this to be number size. Equal layout extend layout array, and this is actually going to be union size, give us the remainder of the body, and then okay, so oh wait, this needs to be I think it's fine to unwrap there because I think it should work every single time. And then let pointer equals safe. I want to yoink this. Don't need you up there anymore, I think. Why? Oh, it's because I haven't not returned it yet. Hold on 1 second. Alright, we're back and going to allocate. Alloc layout, and then do pointer is null. And we'll alloc error and pass in the layout. Otherwise, we mute object. And then just return a pointer. And then that should, like, what's going on here? Oh, I know why. There we go. All right, so now we have this, and then we just need to use the variant. Types equals union. You need that, otherwise you will yell at me, maybe? I don't know. Let's think of this. Alright. It's union. Oh, wait. No. Variants. And do variant as use size. And then we want to then go and get the reference of it. And now this is where we figure out the types and placing of things. So offset equals 0. So for each, this is just a variant. Y variant dot types. And now we'll do a match TY, and we do type. Basically, whatever we did for linker down here. So I'm just going to yoink this. And we'll just change size. To that. That's probably like, these haven't been imported and they're constants. There we go. And so with this, let's see. So current offset equal the member start plus the offset. And so now with this, what we can do is take our task, actually, it's not quite this. That we just ignore. That happens here. This means that what we do is do value equal task dot pop op stack, and let's pop a U8, and then just for simplicity, that's fine. Pointer dot byte offset, byte offset, byte add. Want to add the current offset, set it equal to value. Because this is in the wrong spot. There we go. And basically just do this. This will be an AU16. And then this, it doesn't really matter which one it is, because that's just the it's just the same size, so it doesn't really matter. I don't think that would cause any undefined behavior. And then here is honestly the same as this, because a pointer is that same size. And so there we go. So now we can construct a union. Let's write a program. So do that. Open it up. Let's be here. Runtime src main. And now we need to write something. Let's just copy our hello module. And let's add a union to it. And so we don't have any effects, so let's just remove you. And we'll have, it can be called hello main. We'll move this into the test thing. I just want to be able to run it. So parameters. That actually doesn't make any sense for this, so I'm just going to remove that in both spots, because main does not take in a string at all. You don't have any effects that you release. And so we'll just alloc name will be maybe, variant will be nothing. Let's call it none. Let's call it none. And then we don't want to do anything. We just want to allocate and then leak memory. And start is union main. And now we construct a union. Hi union. And I forgot you have a name, which we'll put maybe. Variants. Should do a vec. Why are you complaining here? That is indeed an expression. Maybe it's because this thing is messed up. Variant. I think that's how it goes. It's been a while since I looked at it. And that is maybe not it. Union variant, yes. Name and fields is a type. Oh. Where did, okay, I made it up over there. All right, so name is just, let's do some, let's be Rusty. And types is going to just be a type hi type built in hi type I64 And then we add another variant, which is none, which doesn't have anything. Why is it complaining? Oh, I messed up the allocator. Use the alloc layout. That's probably why I was complaining. Let's put it right here. And then, yeah, I need name. Let's see, come on. Alright, what is it? Fields. Alright, so oh, hold on. Are variants in the wrong order? Maybe, that is annoying. That is actually kind of annoying. Now thinking about it, is we need to read the variants in reverse order. I need to fix that. I'll do that some other time. But basically the issue is, since we evaluate from left to right, by evaluating from left to right, that means the stack's now in the wrong order for popping. For 1 it's fine, but for 2 it's not fine. So that is not great. Let's add union module. And so union module. Oh, that's not where I wanted to go. Do union. Let's do a cargo build and cargo run, and we index something out of bounds. Great. So that is in raw 395. Where is that? 395. So the iterator for the unions is messed up, which will take forever to figure out. So I'm just going to end the episode here, and you'll have all the union stuff implemented by next episode. So see you guys later. Goodbye.